Okay, so step one of the heparin protocol is we got to account for the patient's weight. When the patient's weight's in pounds, we need to convert that to kilograms. So you hopefully remember that you would just divide by 2.2, and then I think you get, what, 50 kilograms? Let me just double check. So 110 divided by 2.2, yeah, 50 kilograms. All right. So the patient's weight in kilograms is 50. So that's step one. And then if you look in the protocol, that's essentially step one of the protocol as well. Step one of the protocol is we need the patient's weight in kilograms required for order to be processed. Patient's weight is 110 pounds. We're going to convert that to kilograms. So on your test, really the only way that I was able to kind of change what happens here is we change the patient's weight. So for additional practice, you can use your weight, your dad's weight, grandpa's weight, friend's weight, fictional weight, whatever weight you want to use that weight. So if you want to use like 215 pounds, if you want to use 176 pounds, if you want to use 98 pounds, try that and then try the steps that I'm about to show you. And that'll be a way for you to make up different heparin protocol questions. And as long as you tell me the weight that you use, I can tell you when you get to your final answers, if you got it right. So if you want to email me once you've tried a different weight, and then on the YouTube channel, I have done maybe one or two other questions where I used a different patient weight. All right. So we got the weight in kilograms first. Now, the first question says to calculate the number of milliliters to administer for the bolus. So we need to know first and foremost what to do with the patient's weight and with the bolus. Now, if we go back to the beginning of the protocol or the beginning of the question where it says bolus the patient with heparin 80 units per kilogram body weight. So it's right here at the very top. And I know this is blurry on here. I apologize. Once I move my hand, I think it comes out a little bit better. And at the bottom, it tells you the same thing, bolus with 80 units per kilogram. Okay, so we're going to start with that. We're going to bolus the patient with 80 units per kilogram. So we know the patient weighs 50 units. We're going to multiply by the 80 units per kilogram. 50 times 80 gives us 4,000 units. Now, if the question had said how many units to administer, we'd be done. But unfortunately, that's not what it said. It said how many milliliters do we administer to the patient. So we need to go to our protocol, and we're going to look at step 2 of the protocol. Step 2 of the protocol tells us two important pieces of information. It says that we have available a heparin 25,000 units in a 250 milliliter half normal saline. So that's our IV bag. And then we have a bolus dose available of 1,000 units per milliliter. So we need to know this in order to calculate the bolus dosage strength in milliliters. So since we know it's 1,000 units per milliliter, you're just going to set that up like that, and then use your calculator to get a 4 milliliter bolus dosage strength. So this right here and this right here will be consistent for answering the bolus dosage strength question, unless for some reason the bolus dose were to change, but that would be clearly indicated in the protocol, okay? And what I mean by that is if you go down and look at steps 11 through 15, it'll tell you to do different things like rebolus with 80 units per kilogram, rebolus with 40 units per kilogram, or you don't rebolus at all. It just depends on what the protocol tells you to do. So 4 milliliters is the answer for question A. Question B then says to calculate the infusion rate in milliliters per hour for the heparin IV drip. Again, going back to the beginning where it says start a drip at 18 units per kilogram per hour. And that same information is repeated right here where it says start a drip at 18 units per kilogram per hour. So step 10 in the protocol repeats what the initial question said at the beginning. Okay, so 18 units per kilogram per hour. Now we're talking about with kilogram, we know we're talking about the patient's weight. So we're talking about the same patient that still weighs 50 kilograms times that 18 units kilogram hours. We're going to multiply 50 times 18, and we will get 900 units per hour. Again, if we wanted units per hour, we just leave it there, but we want milliliters per hour. So I need a way to convert units to milliliters. The protocol tells us how to do that. The protocol says that we have available heparin 25,000 units in 250 milliliters, half normal saline. So I'm going to take that piece of information. So 25,000 units, 250 ml. And that's how you would calculate the drip rate. Before you do any math, you can just double check. We eliminated units. We're left with milliliters per hour. So we know we've done it right. Okay. You plug that into your calculator, 900 times 250 divided by 25,000, and you will get 9 milliliters per hour. As far as things that are consistent, as long as we're talking about the initial bolus and the initial infusion rate, these pieces of information, the 18 units per kilogram per hour and the 250 milliliter per 25,000 units, will be the consistent things that you would see for calculating the initial drip rate. For C, part 1. So C part 1, we're basically going to repeat what we did in part A. C part 1 says, or C says, after 6 hours, the patient has an APTT of 43 seconds. So we're going to go into the box here and we're going to look for our APTT. We can see that step 12 fits that range of 36 to 44 seconds. And then we just do what it says to do in the range. It says to rebolus with 40 units per kilogram, and then to increase the rate by 2 units per kilogram per hour. So I guess what this is telling us is that the patient is still having clotting issues. And so we want to readjust and give them a boost of heparin in order to help them stop prematurely clotting. So step 1, rebolus with 40 units per kilogram. And then the question for C part 1 says to calculate the number of milliliters to prepare. And that's supposed to be for the new bolus dose. So same patient, same weight, but a different bolus dosage strength. So initially we did 80 units per kilogram, but now the protocol says to do 40 units per kilogram. 50 times 40, we know we've set this up right, gives us 2,000 units. And then we're going to convert units to milliliter using that same bolus dosage strength that we have on hand from step 2 of the protocol, which is right here. 1 milliliter, 1,000 units. We eliminate units and we get 2 milliliters. Now, if you automatically said, well, if 80 gave us 4, then 40 would give us half, which would be 2, you did that right. Okay. I'm just showing you this as an extra, extra practice for setting this type of question up. But notice that I followed the same flow that I did in part A of this question. C1 follows the same flow as part A. C2 is going to follow the same flow as part B. So let's do that real quick. So same patient weight, but we are changing the infusion rate. The infusion rate says to increase it by 2 units per kilogram per hour. Now, that doesn't mean we go from 9 milliliters per hour to 11 milliliters per hour. That would make things a lot simpler, but that's not what it said, because that's milliliters per hour, not units per hour. We're going to adjust this initial unit per kilogram per hour by 2. So 18 plus 2 will give me 20 units per kilogram hour. $50 times 20 gives me 1,000 units per hour. And if you notice, one of the previous questions, question 22 uses the same 1,000 units per hour, and then tells you to convert it to milliliters per hour. That's why I was saying some of the questions prior to this warm you up to these questions. So again, I don't want units per hour, I want milliliters per hour. So I'm going to convert, and I'm going to use the same IV bag that the patient's already connected to, and we're just going to adjust the flow rate. So it's still that same 250 ml, 25,000 units. Heparin. Get rid of units. We're left with milliliters per hour, and then we'll get 10 milliliters per hour. Okay. So the only thing that I can really change on this question is the patient's weight. So that's why I was saying, for additional practice, just come up with a different weight, whichever weight you decide to use, and then that'll be the patient's weight to use for calculating different values of the protocol. Now, you might get decimal answers. Just remember, round to the nearest 10th, and then even in your flow rates, round to the nearest 10th. You can't assume one way or the other unless you actually are working with these protocols, like how they would actually like specifically round it up. So like, let's say you got like 9.8 milliliters per hour, you probably would just round that up to 10 or round it down to 9 in reality. But in the math situation, round to the nearest 10th. Okay. So don't get hung up on those details. All right. So yeah, that was someone had asked in the previous thing that had open, they had asked about doing the heparin protocol. And I believe this is the first time you guys are seeing the heparin protocol. So, and then I've also created, I've rewritten this up a couple of different times on on YouTube. So you have that available to you if you need to review it again. And as I said, the only thing I can change really on this question on your test is the patient's weight.
Dr. Rad, I have a question.
Mm-hmm.
If the weight was, for example, if the weight was 50.56, should we round it to 50.6, right?
Correct. Yes. So that's a good question.
Okay.
Yes. So like if you're doing a patient's weight and when you convert it to kilograms, go ahead and round the kilograms at the beginning to the nearest 10th. At least that's how I figured that out when I created keys and things like that for when I've made the tests. Is I went from pounds to kilograms, and then I would at that point round to the nearest 10th. I wouldn't wait to round at the end. But what I have found is doing that when you have big numbers, the rounding at the end, you're still going to get to the same answer. So round, once you go from pounds to kilograms, round to the nearest 10th at that point.
Thank you.
You're welcome. Any other questions from this practice sheet?
Can you go over the ones you said would like warm you up to the heparin? I think you said it was like 22.
Yes. All right. All right, so the questions that warm you up to question 22 are, or I mean, I mixed these up. Oh no, I didn't. I forgot. The ones that warm you up to the heparin protocol are questions 22 and 23. So 22 is the one with the 0.45% normal saline, and then 23 is the one with 0.9% sodium chloride. So let's look at that. So 22 says we have an order of 0.45% normal saline, 1,000 milliliters IV with heparin 25,000 units to infuse at 1,000 units per hour. What is the flow rate in milliliters per hour? So what I'm going to do is I'm going to set this up very similarly to how it was set up in the heparin protocol. Since we already looked at that, I would take the 1,000 units per hour. Okay. Then I would multiply by my IV solution. My IV solution says I have 25,000 units of heparin in a 1,000 milliliter bag. Then I would multiply across the top, divide by the bottom, and then see what we get in milliliters per hour. So 1,000 times 1,000. Divided by 25,000 will give us 40 units or 40 milliliters per hour. So again, it looks very similar. Obviously, what we have available for heparin is different, but the setup is the same. That's why I call these like warm up or practice for the heparin protocol for the second part of the heparin protocol, the calculating the infusion rate. For 23, I'm going to follow the same thing. It says we have 500 milliliters IV Humulin R regular U100 insulin 500 units to infuse at 10 units per hour. So now we're using insulin instead of heparin, but notice that it's still units, right? So when we're doing math, we really don't care what it is. We just want to make sure we know, like we have units, we have milliliters, we have the things we need to do the conversions. Then we have available we don't want units, we want milliliters. This is a 500 milliliter solution that contains 500 units of insulin, and then kind of made that a little bit easier than it needed to be, okay? Because we can just eliminate the 500 and it would just be the same flow rate of 10 milliliters per hour. So the benefit of doing 22 and 23 is it just helps to warm you up to calculating the flow rate in the heparin protocol. So that's what I meant by that. If you're sitting there saying like, I don't get it, how is this even related? It's somewhat related. So.
Is there only going to be one heparin on the test, the heparin problem?
Yeah, there's just the one heparin protocol that will have two questions.
Thank God.
You answer both questions, but like I said, if you and usually it's just the bolus and then the infusion rate, and then once you've done that, that's it. That's all you have to do. So I gave you 4 to practice, but there's only going to be 2 of the 4 asked. And like I said, it'll either just be A and B, or it'll just be C1, C2. And from what I recall, it was just A and B, but sometimes they may have changed the test. So with a little bit of practice, you'll be able to answer that. And then, and like I said, if you miss one or both of the bolus and the heparin drip, which I don't think you're going to miss them, you only miss 1 question there. So it doesn't count as 2 questions. So if that makes you feel better or worse, I don't know. Any other questions?
So I have a question on number 15. It was like with the two insulin medications.
Mhm.
I got it marked wrong last year because I put, so you draw up the regular first. So I had that in the back towards the like 40 to 50. And then I had the NPH in the front. And the person grading the test marked it wrong. But isn't that correct?
Yeah, that's correct. So, we've gone back and forth on this over the years. Actually, it's been a while. Because when I had initially written out the key for these, I had written it out the way that they were probably grading it, but I thought that got corrected like maybe 5 years ago. So I apologize for that, but I would just say you should be able to fight for those points if for some reason they're not giving it to you, but you did that right. Yeah. So if you have 10 units regular, 40 units NPH, you would put a total mark at 50. Okay. So you'd put a total mark at 50. And then your regular would be indicated at between 40 and 50. I think that's what you just told me. So like if I was writing that out, here's my total. And then my regular is between 40 and 50. So it's in this range here. It's completely hypothetical because in reality, it's not, but that's what they're asking you to identify. And then the rest of this here would be your NPH, which I believe is what you told me. So if you drew it up similar to what I have written here, you did that right. And then I would just make sure when you're marking this, when it says amount to be drawn up first in the solution, do regular first and then 10 units. And I would just make sure you write it here, 50 units total. That way there's no confusion over what you're supposed to do. But doing this on like on a piece of paper that's flat, and then we're supposed to believe that it stays close to the plunger side when we're done. I know that can be baffling even to the person grading it. So. Okay, we've got question 21. So question 21 is the Pfizer pen question. Question 21 states that you have an order of Pfizer pen, 350,000 units, IM, stat Q6H, using the information below, choose the strongest concentration and determine how many milliliters you administer to the patient. So I do believe you had something similar to this in your last semester's test. Okay, so this milliliters diluent added, we just ignore that column because that just tells the pharmacy how much deionized water to add to get to these concentrations here. Okay, so the strongest concentration is going to be the 1 million units per milliliter. So setting that up, 350,000 units, 1, 2, 3 is the order. The strongest dose is the 1 milliliter and then the 1 million units. You plug that into your calculator and you will get 0.35 milliliters. And then that would be your answer. You don't round that to 0.4. And the reason you don't round is because a number less than 1, you round to the nearest hundredth. Okay, so don't round that number up. If this were 0.352 or 0.357, then you would change this number when it's appropriate. So if this was 0.357, you would round that to 0.36. But don't round to the tenths. Any number less than 1 is going to be rounded to the hundredths place, assuming that that is available in the question. And then as a little shorthand, we have 4 zeros here. I can cancel out 4 zeros down here. 35 divided by 100 is much easier to calculate on your calculator than is 350,000 over 1 million. But if you're plugging it all in your calculator, just make sure you didn't skip a zero. Please, please, please.
Thank you.
You're welcome. And I don't know if you're picking up, they're grabbing the garbage at my office, so it might get a little bit loud here in just a second. Any other questions? $17. Okay. All right. So 17. Okay. So 17 says your patient is to receive Solumedrol 200 milligrams IV. It's received from the pharmacy in a 75 milliliter bag of dextrose 5% water to infuse over 30 minutes. Drop factor is 10. No other IVs are running. What is the flow rate in drops per minute? So what we're going to do is we're going to take, so this is number 17. We're going to take our flow rate, which is 75 milliliters. And it's infusing over 30 minutes. We're going to multiply by our drop factor, which is 10. And we're going to get, I believe it's 25 drops per minute, but let me just double check. So I'm going to take 75 times 10 and then divide it by 30, and I'm going to get 25 drops per minute. So the secret to doing these, if you may recall from last semester, flow rate times the drop factor is how you calculate drop rate. So flow rate times drop factor is how you get to the drop rate. All right. Well, if you don't have any other questions, you can certainly continue to practice through the sheet. The practice tests, I may be adding a few extra like practice questions that might be helpful. Some of them are listed for 4th semester, so just keep that in mind. But they would still be applicable to you guys for 3rd semester. So don't get hung up on what that is, so you can try those out. And then for the heparin protocol, just try some different weights. And if you want to email me what you try, and then I can give you feedback. Once all you need to do is tell me the patient's weight, and then I can tell you if you got the answer correct or not, and then help you troubleshoot if you missed something. Or like I said, I'll be here this afternoon for 3rd semester, and then I'll also be here on Thursday. I have 2 times on Thursday that you guys can meet up with me as well.
Dr. Rat, when you say 2 times, it means you're available in the morning and evening.
Well, it's afternoon and then later afternoon is how I qualify it. So like we have this time from 1:15 to 2:15, and then I think it's 6 to 7 or 5:30 to 6:30, I think is the next time that your class meets.
Okay, got it.
Like
Thank you. Mhm.
You're welcome. Yeah. I'm going to look that up real quick because I can't remember off the top of my head. And I should know that.
Is the one tomorrow 2:30? Is there one tomorrow? Or no?
No, Thursday. So just today
Okay,
and
'cause
Thursday.
I want to get a chance to do the practice thing because I really didn't get a chance to do it for real, and then I want to ask questions.
Okay. Yeah, that's what I assume that some of you didn't get a chance to practice some additional or to practice yet. And so you just kind of wanted to see what other people were asking. And yeah, I would say go ahead and do that. You might go through and be like, oh, okay, I got this. It's no big deal. Or I need more help. So I will be here on Thursday as well.
Thank you.
You're welcome.
Thank you, Dr. Rat.
Yep, you're welcome. Good luck on your test if I don't see you guys anytime again. So good luck.
Thank you.
You're welcome.